Well, continuing on a theme, super excited today to get Rob back to CTO Craft on Back to the Code, why CTOs must get technical again to solve AI's real problems. Please welcome Rob.
Thank you. Okay. All right. So I had an opportunity to hear Andrew Ng speak recently, deeplearning.ai, sort of creator of DeepMind, I guess a thought leader, innovator in AI. And he told a story that I thought was really interesting, where he was working on graphics for a project that he was working on, and he was struggling to get the results that he wanted. So he enlisted a friend who has a background in art history, and his friend created much better graphics through prompting an LLM, because his friend's language was much more sophisticated, right? His friend had the words to use that created the outcomes that he was looking for. You can tell where I am on the spectrum because my kindergarten drawing and my impressionist drawing are basically the same drawing. So I clearly don't have those skills. But as we learned yesterday from Luca, things that are good for AI are often also good for humans. And so the way that we communicate with the humans in our organizations is very tied to our ability to understand the subject matter, right? This is from Amanda Goodall, who's was on an HBR podcast, but she's a professor and researcher around high-performing teams, high-performing organizations. And one of the conclusions that she's come to through her research is that organizations led by experts have better outcomes, right? Higher performance and better job satisfaction for the folks in those organizations, right? So if the person, you also have to be a good manager and a good leader, but if you have expertise, then you have the ability to motivate and to help the people in your organization, because again, you can communicate with them as a subject matter expert on the work that they're doing, as opposed to more general manager. And they looked at this across hospitals, sports teams, organizations, government, like across the board. So, this is you building your expertise right now. Like, we've all been on the ladder of growth over the course of our career. And I feel like we all just stepped on square 88. Hopefully everyone's familiar with Snakes and Ladders. I think it's a pretty international game. And slid down to square 24, right? Like, everything is different about what we're trying to build and how we're trying to build right now. And so our expertise, right? A lot of technical leaders are able to lead based on the things that they've done over the course of their career, right? But that expertise has suddenly regressed in terms of where we are and the level of knowledge and understanding that we have. And so faced with a market that's telling us that, like, you don't even need the engineers that you have. We're going to stop hiring engineers, right? And the engineering job is going away, and your folks are looking to you saying, like, what is this? How do I act in this world? Or even better, you come to CTO CraftCon, and someone stands up on stage and tells you that, Salvatore is 5 times as productive as a result of AI. Like, how are you supposed to take that and respond to it, right? So let's talk a little bit about what I mean by being in the code. I would not recommend, there's like a lifelong debate, I think, in engineering and engineering management about engineering managers being in the code, meaning, am I shipping, Jiras or linear? I guess linear is the new hotness, right? So am I shipping as part of the team? Definitely not. But I need to understand, right? And I just saw Klaus somewhere. He taught me this word yesterday that I forgot, for like touching to understand, right? So this is kind of how we've grown, right? Many of you, I don't know everyone in the room, whether it's in the organization that you're in now or in your career, you start out as a solo developer, you learn, you do the job, and then you're surrounded by a team, or maybe you have a team of people underneath you who are doing the job, and you learn to sort of get them to do the job. And then you have a team of people who have teams, right? And it keeps going. Then you have a team of people who have teams of people who have teams of people, right? And so at each of these levels, you build layers of abstraction, right? Ideally, you use your domain-driven design and your team topology to build an organization that you can roll up and see from a high level. This is an organization that's effective. This is an organization that's working well. But you also, because of your expertise, you can smell when something's wrong, right? When someone tells you, oh, we're doing this thing, you're like, that doesn't sound quite right. and you leverage that. So that skill is really valuable to you even as you step up and up and up in the organization. So as we operate, our expertise influences how our teams write code. It influences the products that we build, and it influences how we organize. So I want to talk a little bit about each of those, partly status quo and what that looks like today and what's being affected, and a few things about things that I've learned and our team has learned along the way. So first, how our teams write code. Over the years, many years, if you go back to assembly, which is like a pretty long time ago when that was sort of the default way to build, we have invested continuously in increasing the level of abstraction away from the system, right? And that has allowed our teams, it has allowed us as software engineers to achieve more with less, right? I take a thing that I used to have to worry about. I used to have to worry about registers and like where individual integers were being written. I used to have to worry about memory allocation. Then I stopped worrying about that. And then I got to higher and higher, more expressive levels of language, right? Each of those hid something from me that I no longer have to worry about as a software developer. If you go up the sort of compute stack, I mean, I've been in this business long enough that I used to rack and stack data centers. I've crimped my own cables, right? Now I click a button and I have a computer. I don't know where it is. I don't care. But it can do the work, right? And now I can build something serverless, right? Like here's a function, just run the function when it's needed, which is a much, much higher level of abstraction, so I can deliver a lot more with a lot less work, right? Now, I think there's a very flawed conversation that we're having, which is that Gen AI writing code is a level of abstraction above that, but it's not, because you still have to inspect and understand everything that has generated, right? You can't assume that it is correctly implemented, whereas the JVM, plus or minus the odd bug in the JVM, I just assume that it's going to do its job, and I can worry about the layer above it, right? Also, we depend on pattern matching. So right now, we're evaluating ClickHouse. If people are not familiar with it, it's like an analytics database, like columnar database, right? And I don't know anything about ClickHouse. I'm a little bit involved because it's a big expense for us as an organization. It was impactful to our whole company. I don't know a lot about it, but I've worked with a few databases in my life. When people talk about databases, I can say, oh, that makes sense because I've seen that in one of these other databases, data stores, whether it's relational, whether like I've not only coded against all of these, but operated all of them in production. I have enough background to say, that makes sense. That sounds weird. Let's dig into that a little bit more, right? I can give guidance from where I sit. When people start talking about generative AI, like what am I supposed to compare that to? Sometimes I take my dog for a walk, and despite the most explicit instructions to not jump in the bushes, he still jumps in the bushes. So I have that I can lean on. But other than that, like I don't have real experience for what it's like to try to do this job right now, right? So here's a couple things that I learned. And I will say, because I was talking to someone about this yesterday, and they said, well, where do you find the time? And based off Pat's archetypes, for anyone who was here yesterday, like I am a startup CTO, a scaling CTO, and a stable CTO, and a field CTO, and an internal CTO. I'm not spending all of my time writing code, but you don't have to spend a ton of time to learn a lot about how the tools work. So one of the first things that I learned was trying to ask Claude for information, right? I was working on something with someone else where we were trying to get some analytics work done. And we took a data set and said, tell us the answer to this. And it said, well, in this case, what is the likelihood of this hitting this projection? 0%. Okay, great. What do we do with that, right? So then we tried Claude Code and we said, write us a script that tells us the likelihood of hitting this projection. Then we were able to inspect the script, which is back into the domain of our expertise, and say, you did this wrong. Right? You haven't accounted, you've only basically taken a look at the statistical probability based on individual days. You haven't identified the trend and built variance off the trend. I don't actually know the statistics that well, and I don't remember the toolkits that well, but I know what good looks like, and I can say, hey, try fixing this. Claude Code rewrites it for me, of course tells me that I'm brilliant along the way, and I get the result that I'm looking for, right? That's an hour of work, maybe, to come to that insight, right? This is not investing all of my time and energy, but that allows me to then give guidance to folks that I'm working with on things that they can do differently. Separately, I don't know if people are familiar with the concept of inner and outer loop in the software delivery lifecycle. So we talk about the inner loop as, the things that I'm doing as a developer sort of on my laptop, and then I maybe push a PR and hand things off, and then it goes into this long, arduous, painful cycle, the outer loop. I think whoever describes it that way is clearly not a CircleCI customer, but I'll leave that for you to figure out. But what's happening is that we've accelerated a tiny little part, right? Which is the writing. So again, I took, on a Sunday afternoon or something, I had been using a small piece of real code from our CircleCI code base from a service that we don't use a lot, doesn't really matter, because I need to tell you that it's really bad. And I had been using that as an interview question. How would you refactor this section of code? And after watching 5 or 6 people do it and seeing 5 or 6 different implementations, all of which were fine, I got really sick of looking at it because it is actually really bad. And I thought, I'm just going to clean this up. I'm finally going to clean it up. And then I thought, I wonder if Claude could, actually I use Cursor in this case, I wonder if Cursor could clean this up for me. Like, what would it look like? And I said, hey, under these parameters, clean up this code base. Like, simplify these things, reduce the duplication, et cetera. And it took about 2 minutes, and I was like, that is a perfectly good PR. If I can produce a perfectly good PR in 2 minutes, what's going to happen to the rest of the software delivery lifecycle? Now, know that I'm also in delivery tooling. And with that small amount of insight, it's pretty clear that all of the things that were in the right side, in the outer loop, need to shift into the inner loop, or else we will never get anything done, right? We will produce all of this code at alarming rates, and then the rest of our teams, all of our staff engineers will just be reviewing that code, right? Their entire week will be spent reviewing the enthusiastically crafted AI-generated code of our junior engineers. So how do we fix the rest of that, right? It doesn't take very long, again, to get to that conclusion. It takes a little bit of idle time and a little bit of thought, plus just trying it. So what about the products that we're building? Are people familiar with this expression, a simple matter of programming? Or is that just like an Americanism? I'll explain it as quickly as possible. So when we think about large things that we're trying to do, right, there's a lot of unknowns. Oh, we're going to go work on this project. We're going to try to build this thing. There's a lot of unknowns. We want to get to the place where we've broken things down to small enough pieces that any one of those pieces we would refer to as a simple matter of programming. We know this is achievable. We have a rough idea of what it would take to do it, right? We're out of unknowns in this case. And that's a great model. Like, when you're estimating, right? I don't know if people do this, but if you're estimating, you're like, oh, it's 13 story points or whatever your highest thing is, or that's going to take a long time. Then you ask important questions. What don't we understand? How can we break this down to something that we can understand, right? And we can always get it to a place, because we understand software, that we know how to implement it. There is no such thing in prompting. You might never achieve the thing that you're trying to achieve, right? You say, great, now it's down to the fact that we just need to write a prompt that will get us this result. And much like my dog jumping into the trees, like, you will maybe just never achieve that result. And so we really struggle with this concept, I think. And we're in CI/CD, right? This is how we talk about software delivery. It's either good or it's bad, right? It's binary. It's all deterministic. We only think about software in a deterministic model. And people have really struggled with this in the transition to integrating AI capabilities in their products, right? So in this case, we're talking about taking generative AI and including features in your product that we don't know how it's going to respond. We don't know how to deal with that. But the truth of the matter is, I've also had this chart for 10 years. Maybe not this exact chart. Like, we look at our systems probabilistically, right? We look at statistics. We calculate SLIs and SLOs, and we say, oh, under these conditions, it would be acceptable for this to work 99% of the time, right? So we know what it means to evaluate a percentage good in terms of a result for a customer. We need to take that thinking and translate it into how we think about systems built on top of probabilistic capabilities. All right, MCP, hot topic of the day. Again, back to learnings in terms of what we built. Does anyone remember that 1 week period where MCP was the most important thing that you could build in your product? Right? We're going to add an MCP server, and now we are AI. Right? I'm not going to try to explain Wardley maps to you, but if you want to know anything about corporate strategy and ecosystems, you should read this blog post from 2014 by Simon Wardley. Concept is tower and moat, right? So that's at the center of an ecosystem. You have a platform builder, think I don't know if there's a million of them out there, but anybody who has built an ecosystem, let's take a cloud provider, right? You build the core of the ecosystem, and then you let people build on top, and when they build something of significant enough value, you build it instead, make it free, and crush them. That's the tower and moat model. The foundation models were able to execute this in a heartbeat. Everybody wanted to be part of their world, and they said, cool, build an MCP server, and then we will own the customer, and you will provide services to us. They immediately basically took everyone's user interface and ownership of their customer away from them by publishing this spec, right? So we did it too. We were like, oh my gosh, we have to have an MCP server. Everybody has an MCP server. Let's talk about our MCP server. And then we realized there's real value to add, and we need to build real value into our product and own the customer experience and leverage the underlying LLMs to build great capabilities. And I think that if you think about your product strategically at all, ask yourself that question. How do I continue to own a customer relationship? And so for us, I don't know, it's a little embarrassing. I don't know if anyone saw me at the bar last night, but I was posting on LinkedIn because we launched a product yesterday, and like at 6 p.m. here, I had to put my post up. But we launched a autonomous validation agent. It's called Chunk, made by CircleCI. And one of the things that we had to think about as we were doing that, again, is owning that relationship. And I don't know if people are familiar with this workflow versus agent definition that Anthropic has, but basically an agent is a situation where the LLM is making the decisions and then farming out work, through your MCP servers or whatever. And a workflow is a model where you, the code outside of the LLM, is making the decisions and coordinating and then farming out work to the LLM. And so we started out building this thing. It basically fixes flaky tests on your behalf. I shrug, you should totally use it, it's amazing. But we started out saying to the LLM, please fix this flaky test for us. And the LLM would say, on the most basic cases, absolutely, I fix that for you. But when you had a complex case, it would say, oh, if I just return true from the test every time, then it is no longer flaky, which is super helpful unless you're actually trying to test your software. And so we are experienced in building capabilities, and we know what flaky tests are. We have all of the information that tells us which of our customers' tests are flaky. So we're able to take that and coordinate it and use it to drive outcomes and just ask for work done by the LLM. So in that case, on this 2x2, I would describe that as highly constrained. We know exactly the problem we're trying to solve, and we want it to be unsupervised, meaning we've done the work and we want to hand that work back to the customer. If it's a much more open world, then you're going to need some supervision. Like you can ask the agent to do it, but someone's going to check on the result. Someone is still checking on our result, but we want it to be good by the time we give it to the customer. If it's supervised and constrained, that's sort of just a developer sitting in their IDE. And if it's totally, you want it to be unsupervised and correct every time in a totally wide open space, like you're waiting for AGI, you're gonna have to wait a bit. So how we organize, this is a little bit simpler, but I had published on LinkedIn that I was giving this talk, and my friend Laura Taco from DX sent me this chart over the weekend and said, maybe you'll find this interesting. Managers who use generative AI ship, 5-6 times as many PRs as managers who don't. And I was like, that's totally surprising to me. It wasn't what I was thinking about, but now I'm super intrigued. Like, what do I want to make of that? Because I started out saying, I don't actually want you to be in the code all day. That's not the point. But I think that managers are a really interesting persona as users of generative AI tools. Specifically, we have, you can tell I'm into 2x2s, but if you think about different characters in your organization, right? You have characters who have very low amount of technical knowledge. They're just learning. You can give them a very constrained task. They know how to do the task. They might not know why that's how you do the task. And then at the other end, top of the y-axis, very broad understanding, very broad knowledge, first principles thinking, right? Hal referred to that as mental models yesterday. Like, I understand why this works, therefore I don't have to have the sort of rule of thumb to make it work. Junior ICs, at the low end, maybe they understand. Oh, and sorry, the other direction I'm just going, like, how current are you with tooling, right? And your very senior ICs, Staff Plus, they're super current. They have all the shortcuts. Like, watching them type is like watching an LLM, except they're faster and more correct. But managers typically have a lot of that knowledge, but maybe aren't super current with the tooling, right? I personally, I don't remember the APIs or the SDK that I would use to do this thing. And so I say, never mind, I won't bother doing that. It would be useful, but I won't bother doing it. But when I don't have to remember any of those things, but I can tell that the work that was done is correct, then an LLM is super valuable to me, possibly more so than that staff engineer, which is an interesting character. Again, I'm not necessarily saying you should sit down and go back to writing code. But if you think about unblocking your team, like this thing came up and no one knows how to do it, I know about it, why don't I just get that out of the way? There's some really interesting models that float in there in terms of how you could take an approach and operate. All right, so to wrap it up, I think it's important as leaders to be both credible, meaning I know enough, I can talk intelligently about the thing that we're doing, and to be empathetic. Like saying, hey, you should be 5 times more productive because Salvatore is 5 times more productive is not particularly helpful to the people on your team. Understanding what the limitations of the tools are and what the capabilities of the tools are that you're asking them to use is very helpful. So understand what it's like to do the job now. Not the way that you did the job when you were first learning, but how you're asking your team to do the job now. Be prepared to think about the right questions for the product that you're asking them to build, again, as you integrate AI technologies. And then take advantage of the tools to help where you can, but don't put yourself in the critical path and block your team. That's going to be helpful. And lastly, a couple finishing thoughts. It's totally fine to not actually know what you're doing. Don't go off in a cave and try to become the expert so you can tell everyone because now you're the expert. It's a great opportunity to work together and bring folks along, right? Showing that you don't know either, but you're excited to learn is a great opportunity for you and your team. We have this brand campaign where we talk about we are engineers and talk to individuals about how they got into engineering in the first place, what inspired them, and no one yet has said memory management. They talk about building exciting, like I was excited because I learned that I could build a thing, right? And so the way we do that work is changing, but the core of being excited to build great products for our customers still exists. And if you can embrace that energy and bring your team along, I think you'll be in a much better place. Awesome, thank you.
Rob. There's definitely a couple of questions up there, but do get your questions on Slido. I think we've got about 3 minutes. First one, what are the key failure patterns you've seen with AI proofs of concept that don't scale?
I just want to thank Irina. I don't know who you are, but your great job. Amazing question at every talk. So first of all, I think that assuming that anything has to scale is problem number one. One of the things that I think about proofs of concept, are people familiar with the painted door? Like I implement a fake piece of product to see if anyone clicks on it. Like click here if you're, whatever. Oh, sorry, it's not working today, or here's the waiting list or whatever, right? Like now we can put almost a functioning piece of product in there, which gives us much better insight. The reason we do that, by the way, is it's very expensive to build scaled product, right? It takes a lot of engineering time. It should be your last option. I want as much information as possible about the things that I'm considering before I actually make the investment to go build the first version of that thing, let alone continue to build on top of it, right? And so believing that it has to scale is actually the bigger problem right now, I think. Knowing then, and I guess the other thing that's great about AI-generated proofs of concept is they're super cheap, right? Like one of the reasons we keep things that aren't great is people have emotional attachment to them, right? Engineers build emotional attachment to features they built or whatever. I get in trouble a lot because I'm very flippant. I'm like, oh, we don't need that anymore. Let's just shut it down. People are like, I put so much time and energy into that. But when it took you an hour and it was like a fun exploration, I think you have more opportunity to throw that out.
Good stuff. Next one, what are your team? I'll do that one. I started, so I finished. What do your teams expect of you and your AI knowledge?
Yeah, I'll try to be, what do they expect of me? The same nothing that they expect in all other conditions. I think to the point of being comfortable not knowing, right? I think the most important thing that I do in my organization now that it comes to me is admit that I don't know and admit that it's not perfect, right? Like I have to de-hype the external conversation so that engineers in my organization will have faith in what I'm actually saying to them to get them to engage in the real conversation. If I say, it's magic, we're all going to be 100% better, look at all the, why are you even taking so long just to use AI, then people will stop listening to me.
Just quickly then, we'll get this. You mentioned not to become a bottleneck, but what about taking issues that you know for speed, but that takes a learning opportunity away from your team?
Yeah, I think I see what you're saying there. So separate topics, like I would unblock a stuck team, right? If it's like, hey, we're trying to get this thing out, we're under pressure, can someone do this thing? Or nobody wants to do this, it's an annoying task. Those are the kinds of things that I would personally pick up. Not looking to take away learning opportunities. I think the other thing I would say about learning opportunities is in all of this, it's really important to make space, right? I think a lot of leaders are saying, I need you to go do this other thing because it's important to us, the world is changing, we need to understand it. And engineers are thinking, but you told me I had to ship this thing by Friday, and I know how to get that done by Friday using the tools that I know, and saying, no, it's okay. Like, these things are less important than us learning this tooling. Right? We're going to take the short-term pain for the long-term gain, making that very public and acknowledging that, because without it, I think people are just all compressed for time and not willing to make the investment themselves.
Great stuff. Well, we're at time there, Rob, but thank you so much for that one. Hand for Rob.
Thank you.